So common factoring and simple factoring, simple trinomials are the easiest of the type of factoring I ask. Well, there's one other one that I think is easy as well. The one that I know we get hung up on sometime are the other trinomials. So these are ones when a is not equal to 1. So you see that there's a number out front here or here. So again, I'd like you to take a second. I'll ask the supply teacher to pause the video for a couple of minutes, and I want you to work with your elbow partner and factor these. And you may have different methods. There's lots of different methods. I'm going to show you a few. My favorite is TV tray. If you haven't heard of that, we'll try and explain it here. But you could use decomposition, you can use bracket line. There's various different methods. So I want you and your elbow partner to remind yourselves of the method that works best for you and try these. And then we'll come back together and see what we come up with. Okay, so hopefully you've had a chance to try these and compare with your neighbors on different methods. I'll show you a couple of methods that I use, but we'll make sure that I don't care what method you use as long as you're comfortable with one of the methods and you get the correct answer. So for the first one, we have 6x squared plus 11x plus 3. So the way I do these is I set up TV tray. So I set up a small little TV tray off to the side. So it looks like those TV trays, you know, that fold up, those little portable tables that fold up. And on the left side of the TV tray, I write down the factors of 6, and it could be any factors of 6. I don't know which one it is first. It could be anything, but I know that it could be 6 times 1, 2 times 3, I don't know. So I'm just going to guess 2 times 3. And on the other side of the TV tray, I guess factors of 3. And it could be, well, it's either 3 times 1 or 1 times 3. Again, I'm going to guess. So this time I'm going to guess 1 times 3. And my goal is to serve up the middle term. So in this case, an 11. So I hope to serve up on a TV tray an 11. Now I check my TV tray to see if I am correct. I do that by checking the sum of the multiples. Okay, so I'm going to go off and I'm going to do the multiplication on the legs of the TV tray. So I'm going to do this multiplication, which is 2 times 3, which in my head is 6. And I'm going to add the up multiplication, which is 3 times 1, which is 3. So I got 6 and 3. Unfortunately, 6 and 3 don't get me an 11, doesn't serve up an 11. So my legs of my TV tray aren't set up perfectly yet. Now I could have done this perfectly the first try, but I wanted to show you what happens if you don't get it perfect on the first try. You simply either erase or scratch it out. I usually just scratch it out and guess something else. But with the advantages of technology, I'm just going to undo. So instead of 3 times 1, or 1 times 3, I'm going to put a 3 and a 1. Now I need to serve up the 11. So I'm going to check those legs now. So 2 times 1 is 2, and 3 times 3 is 3. Or sorry, 3 times 3 is 9. The 9 and 2 does get me an 11. And so the legs are set up the way I want, and I'm ready for dinner, so to speak. And now my factors are right on the legs. It is 2x plus 3. The legs actually duplicate that, but you can just read them right there. 2x plus 3, so one of my factors is 2x plus 3. And the other one's on the bottom, 3x plus 1. Or I just circle those. I really don't write the x's down there. And so the other factor is 3x plus 1. And that is the correct factors. Again, you can rainbow that to double check. And the order in which you've done it, maybe you will have the 3x plus 1 first and the 2x plus 3 after. It would be allowed. Now, if any of you had Miss Hollett, she likes this method. Similar to it, she likes to write down double bars and write down all the factors. I'm just going to, need some more room when we use her method. So she writes down all the factors of the first term. So 6 is either going to be 6 and 1, 1 or 6, 3 and 2, 2 or 3 on one side. And then on the other side, she writes down all the factors of 3, which is 3 and 1, 1 and 3. Now, technically, you don't have to write down both combinations on the left and right side, but I know she sometimes does both. Regardless, you do a similar investigation. You're looking for the combination when you do the down products or the cross multiplying there that you get an 11. And so you can see here we've got 3 times 3 is 9, 2 times 1 is 2, so 9 and 2 is 11. So this is the 2 that you want. And then when you go to write it down, again, you read straight across. It's 3x plus 1 and 2x plus 3, which is the same as that. Okay. So those are your two most popular. There's one called bracket line, which I can show you if you really, really want to see it. I don't think any of the teachers teach it here. There is a third method called decomposition. I'm going to show you right now, but you may or may not follow this, and you may or may not have seen it. And I don't care whether you have or not. If you like it, you can use it. If not, that's fine. So this is called decomposition. Some people like it because it's similar to factoring simple trinomials, where you have to find two numbers that multiply to something and add to something else. The difference here is instead of finding two numbers that multiply to 3, you actually got to multiply these two together and find two numbers that multiply to 18. So 6 times 3 is 18. So you find two numbers that multiply to 18 but still add to 11. So if we think of things that multiply to 18, of course, 9 and 2 come to mind, and 9 plus 2 is 11. So 9 and 2 are the numbers. Unfortunately, though, it doesn't get us the answer right away. What you have to do is decompose this 11x. You break it into these 9 and 2. So the 6x squared stays the same, but the 11 changes into a 9x and a 2x, and then the plus 3 stays the same. So the 11 has decomposed into these two magical numbers that we found, 9 and 2. We do that so that you can factor groups of these. So you take the first two and you common factor those two numbers. So if you look at this, common factor is 3x. So if you take out a 3x between these two, you're left with 2x plus 3. You do the same factoring over here. The only common factor with 2x and 3 is a 1. So you common factor out a 1, which doesn't really look too exciting. But if you've set this up properly and you've chosen the right magic numbers and all that sort of stuff, you'll end up with two factors here and here, which are actually common factors to the whole thing. So since they're the same, you can rainbow them out. So 2x plus 3 gets rainbowed out or common factored out. And you're left with 3x plus 1. If you divide each of these terms by 2x plus 3, you're left with a 3x in the first term and a plus 1 in the other. And that is another way to factor. If you check back, you'll see it's exactly the same as these methods. Okay? So again, some people learn decomposition and they like it and they're stuck with it, and that's totally fine. It does involve a bit more work, and it does get challenging when these numbers here get very big. Then you got to multiply them and get a really, really large number, and you're finding two numbers that multiply to 264 and add to 8 or something like that, and it gets a bit more challenging. So there's decomposition, there is bracket bracket line, which I can show you later if you'd like. The one you'll see me use most often is TV tray at the top, or a variation of that is Miss Hollett's method as well. So we've seen those, but you'll use whatever one you're most comfortable with to try B. I'm going to go off and do it using TV tray. Again, TV tray is just some scrap work that we do off to the side. So I have to serve up a negative 13. I think of factors of 12, which I'm just going to guess at 4 and 3. Factors of negative 4, I'm going to guess. Well, first I'm just going to guess 1 and 4. I know one of those has to be negative because it's negative 4. But before I do that, decide where the negative goes. I'm going to try and test it. So if I go, if I cross, so I've got 4 times 4 is 16, and 3 times 1 is 3. So 16 and 3 is definitely going to somehow get me a negative 13. So I'm just going to add the negative to get a negative 13. So since I need negative 16, I want this to be a negative. So it's 4 times negative 4, and this is going to stay positive. So that'll get me a negative 16 and a positive 3, which is going to get me negative 13. Put your negatives on these ones. Don't put it here. Okay? We don't like to have the first part of your factors with negatives. We like those clean. We'll put negatives here if we need to. Okay? So regardless, I should see my answer. 4x plus 1, 3x minus 4. So 4x plus 1, 3x minus 4. This is the one I want you to practice. It's been a while since you've done this. Some of you, it's been a year since you've done these. You have to practice these. We need to be able to factor these at the drop of a hat. Okay? All right. So there's your other trinomials. Very quickly, the last type of factoring we're going to look at is difference of squares. These ones I find really, really easy. You'll know you have difference of squares because you'll have two conditions. One, it's a difference. That means you have to have a minus between them. And they're squares. That means they're perfect squares. That means you can take the square root of them. So 81 you can obviously take the square root of, but x you can also take the square root of. Or sorry, x squared you can take the square root of. It's x times x, just like 81 is 9 times 9. But I'm pretty confident we remember this one. We take the square root of the first, square root of the second. They'll be the same. So x squared is x times x. 81 is 9 times 9. And then you put a plus between one of them and a minus between the other, and you've got difference of squares. I'll give you a second to try B. If we need to push pause, go ahead. Okay. So again, square root of 16x squared is 4x and 4x. So I'm going to get a 4x here and a 4x here. And 1 is a perfect square because the square root of 1 is 1 times 1. So I end up with a 1 here and a 1 there, a plus between one, a minus between the other. Again, it doesn't matter if you write the plus first or the minus first. So you could write 4x minus 1, 4x plus 1. That would still be the same. That'd be fine. And this last one, so again, I'm going to give people a chance to try it. First glance, you look at it and say, it doesn't look like a difference of squares, because the square root of 18 is not a nice number. Square root of 50 is not a nice number. So how could this be actually difference of squares? Well, we got to remember when we factor, difference of squares might not be the first thing we look for. The first thing we always look for is a common factor. So this actually has a common factor of 2. So I can common factor out of 2 and I get 9x squared minus 25. Then what I'm left with in brackets is indeed difference of squares. And that's a 3x plus 5 and a 3x minus 5. Don't forget the 2 doesn't disappear. It's still a factor. But the other part is now difference of squares.